Let's spend a few minutes in this video talking about the various different file formats that you might run into when you're working inside Photoshop and need to save a file so that you can send it to something else, some other application for use there, or something like a page layout application, or going to email it to someone or put it up on a website, or something like that. So whenever you work inside Photoshop, whenever you open a file, regardless of what file format it is, it's actually getting opened up and converted into a Photoshop document while you're working on it. So I'm going to run you through a variety of different file formats that you might run into and kind of explain what they're used for. And as I said, when you open up a file, maybe whether it's a JPEG off your camera or a camera raw file, at some point when you finally get it into Photoshop, it's getting converted into that PSD, that Photoshop document file format. Now, if you don't do anything to the file and just close it or save it again, it's still going to be the file format that you opened it up as. But if you've done things to the file, like added a layer, added some text or things like that, then we call that the working file. It's going to be saved as a PSD by default. And that working file is what preserves all the layers, all the channels, all the masks or selections or paths that you've added to that particular file. It's important to always keep this working file separate from whatever file format that you're going to end up saving it as. Because if you ever want to go back and make changes, change the type or move things around, of course, you're going to need access to that layered file. That's your original. So you really only throw that away or flatten it down and discard it if you're absolutely sure that you never want to change your mind again. Any other file format you're going to choose from, or at least most of them, you're going to end up creating what we call a flattened version of it. And a flattened file is where all the layers get compressed or collapsed into a single layer, and then you save that flattened version as a different file format. So for instance, if I were actually to go save this file, you can see it's a layered file. There's a bunch of layers. I've just turned them off right now to reveal them as I talk. But this is a layered working file. It's a Photoshop file. If I were to go to File, Save As, and save this as a different file format, let's go ahead and choose from format. Let's choose, say, JPEG. What's going to happen is it's going to say, oh, well, because you're not choosing the PSD format, this file must be saved as a copy with that format option chosen. And in order to do that, I'm going to not be able to save out the layers. So that's why you get a little warning symbol next to the layers checkbox, and it's grayed out because it's not available in that file format. So one little working rule here is you don't necessarily need to do a flatten command. There's an actual command in the layers panel that you'll learn about later where you can choose, flatten, and then save your file. The file can be flattened as part of the saving as process. So I actually tend to recommend people not to do the flatten command because then they accidentally do a save instead of a save as, and they've lost all their layers. So basically, choosing the file format as part of the save as command, doing the automatic flattening in order to create that file is the better way to go. It's a way to protect the original layered file from ever being saved over. All right, let's go ahead and cancel this. And let's talk about some of these other file formats then that you might derive from this layered Photoshop file. Of course, the first one, the one that you probably are already familiar with in somewhat, is JPEG. Now, JPEG is a compressed file format. It's what's called a lossy compressed file format. And in order to save space, to make the file smaller, it actually does throw away original information from the file that may not be all that important. How much information gets thrown away depends on the quality setting that you choose. So at the very high end, the highest quality setting, your eye may not actually be able to notice that anything was thrown away. Whereas if you go lower in the quality, then you actually start seeing things like artifacts and compression artifacts and so forth. JPEG is probably one of the most common file formats. It's typically what people use to email each other. It's what a lot of the online photo services accept. If you use Shutterfly or Flickr or even Facebook or whatever, you're typically throwing up JPEG file formats to those online services. A key thing to remember about the JPEG file format, just keep in mind, is that because it is a lossy file format, you typically only want to save something as a JPEG one time, which is why it's important to keep that layered Photoshop file around. Let me explain. If you open up a file that's already been compressed as a JPEG, and then resave it as a JPEG again, you're compressing it a second time. So every time you open, do something, and resave, that lossiness gets accumulative, and you're actually deriving a lower quality each time you do that. So that's why if you need to make a change or want to do some more retouching or move things around or whatever, you want to go back to the original layered Photoshop file, make those changes there, and then save out a JPEG from that original Photoshop file so that lossiness of the compression is only happening one time. If you're shooting JPEG off your camera, of course, you want to make sure that you're shooting with the highest quality JPEG possible so that at capture time, you're not losing too much information just from the very beginning. Okay, so when it comes time to save this file, let's say as a JPEG, here's our layered Photoshop file, and we're going to do a save as, just like I was showing you earlier. So File, Save As. And from our file format list, we'll choose JPEG. And typically, every file format you choose here, when you choose the file format, when you click Save, you're typically presented with a secondary dialog box for options for that specific file format. So the options of interest on a JPEG, of course, are the quality setting. The default is 5 or medium. These word presets are just presets for a particular number. So if you typed in 10, it would automatically switch over to maximum. If you take the slider all the way over to the right, the maximum value is actually 12, not 10. And maximum is typically the setting you would use if you wanted to archive your final corrected files, let's say, as JPEG. So they take up less disk space, but they don't actually introduce noticeable defects when they do the compression. Of course, when you're just trying to do a quick comp or do an email photo or whatever, throw it up on a web photo gallery where you don't care about absolute highest quality, 5 is a good starting point. You can see as you lower the quality setting, the file size is updating to let you know what that's going to look like. Just to kind of take it down a notch, if I take it all the way to 0, I can see the preview checkbox is turned on. And it may be tough to see over video, but you'll see if I look at the edges of the text here, it's getting all mangled and artifacty or pixelated because JPEG is really compressing a lot of that information and throwing it away. Okay, so again, for archival purposes, you would take it all the way to maximum, and that's fine. Hopefully, again, you're keeping the layered version around if you think you need to do further editing, and if you need to save out another JPEG, you do it from that layered Photoshop file. Okay, so I'm going to hit cancel. Don't be surprised if you choose a file format from your original Save As dialog box and yet another dialog box comes up. It's typically because there are additional options that you may want to choose from. The next file format that's really common for web graphics, at least, is the GIF file format, or GIF. Depends on what side of the country you're from, I guess. And this is also a lossy file format, but from a different perspective. The loss happens before you actually save the file out. In order to save a GIF, it has to be converted into what's called an 8-bit graphic. All that really means is a graphic that can only have up to 256 colors or less. It's typically not ideal or used for photographs. It's more used for graphics, web graphics, areas of solid color, things like buttons or logos or labels or things that you might identify as areas of solid color or high contrast edges on a website. So banners and backgrounds and things like that. So typically what happens when you actually want to save a file as a GIF, you convert it to an 8-bit graphic first. I'm not going to get into that in this video here. We'll cover that later. But typically you're reducing the thousands of colors that might be available in a particular image and telling it to only use a certain set of colors to represent the overall image. So the file size is typically very small because there's just not a lot of color information in it. So those are two file formats most used for the web, JPEG and GIF. There's a third file format that is used for web graphics, but also just interactive content. And that's the PNG file format, or PNG. It's great for working with Flash. It's also a file format that you might use when you're doing presentations. So like working with Keynote on Apple, the Macintoshes, or PowerPoint. And the reason why is that PNG is one of the few file formats that actually supports real nice quality transparency. So GIFs can be transparent, but only one level of transparency, meaning a color can be chosen to be turned invisible or transparent, but it's only one color. So you get a very hard edge, a pixelated edge. PNGs support true alpha channels or masks with 256 levels of opacity, between 100% and 0 opacity. So a nice soft drop shadow that you can actually see through the soft edges, right? The PNG file format is something that supports that. Or if you mask an image out to a transparent background, if you save a file like that as a JPEG, then all those transparent areas will get converted to solid white, opaque white pixels. And that's typically not what you're going to want if you're trying to overlay these files on top of each other and see through around their edges. So the PNG file format is great for, again, PowerPoint, Keynote, and working with Flash and creating interactive content. A couple file formats to talk about for printing that are common that you might run into. The first one is an EPS format, an encapsulated PostScript file. This is kind of an old school format. It's kind of being phased out. I mean, some people still use it, but it's largely been replaced with other file formats. It's something that you typically would see in a print workflow, either using a product like InDesign or Quark or Illustrator. And basically what's happening when you save a file as an EPS, you're pre-rendering or pre-printing the file to disk and then attaching a preview file that travels along with it. Now, it could either be a JPEG preview or even a TIFF preview, depending on which platform you're saving the file from. The key point about an EPS file is that it cannot be modified. Meaning you can't get to the pixels inside an EPS file anymore without reopening it in Photoshop. So you can't assign a color to an EPS file, let's say, once you place it into a product like InDesign or Quark or Illustrator. A lot of production artists like this file format because they're protected. A designer can accidentally assign a spot color to it, for instance. That color information needs to be baked into the EPS as you actually save it out. So when you place an EPS in these other products, again, you're actually just making a reference to the EPS file that's sitting on disk. What you're actually seeing in that application that you place it into is that preview image, just so it can be represented during design time. When you actually print the file, the preview file is not actually used as the printed version. It's actually taking the EPS file and sending it to the printer, and out comes the high quality version of that behind it. Another file format that is common in printing workflows is TIFF. This is a little bit more flexible than EPS files because you can actually assign spot colors to them. So for instance, if you have a grayscale TIFF file, you can apply a color to that and tint it in products like InDesign, Quark, or Illustrator, because the color values of those can be adjusted. So just something to keep in mind. There's different reasons to have EPS and TIFF. A lot of the time, at least in an Adobe workflow, if you're going from InDesign or from Photoshop to InDesign or from Photoshop to Illustrator, you can simply just place your layered Photoshop file. There's actually no need to flatten it or save it out as an EPS or a TIFF. The advantage of that is that you still maintain access to the native original layered file. And in fact, there's a feature called Edit Original. So if I place a Photoshop file in, say, InDesign, it gets rendered and represented as if I had flattened the version in Photoshop before I saved it out. But it's still the layered version behind the scenes. So if I need to make a change, I can just Option or Alt double click on that Photoshop file that's been placed in either Illustrator or InDesign. And it simply opens that original layered file back in Photoshop. You make your change, do whatever you want to do to the file, change the text, move the layers around, whatever it is you're going to do. When you save that Photoshop file, when you go back to Illustrator or InDesign, the updates are automatically applied. So a lot of flexibility, and it kind of makes EPS and TIFF seem a little old school and dated. You'll still run into them if you're a designer and working with others that really haven't quite adopted a PSD workflow between Photoshop, InDesign, and Illustrator. But if you haven't actually started playing with that kind of workflow, I encourage you to check it out. Okay, bottom line, lots of little acronyms and 3- and 4-letter words I'm throwing at you. At the end of the day, the most important file format you really care about is keeping that layered Photoshop file around as long as possible, because it's what's going to give you the flexibility to change your mind. And then when you do have a need to save out a file as a different format for your other purpose, it's as simple as doing File Save As. Don't bother doing the flatten command. So you don't need to go to the layers menu, the flat menu of layers, and say flatten image first. Okay, just skip that step. Instead, do File Save As. Choose the file format that you are interested or need, whether it be PNG or JPEG or whatever. Let's do PNG for this. As part of that Save As process, it's automatically going to save out a copy. It's not going to save over the original PSD file. You'll see it's picking up the PNG file format. It's giving you the warning sign to let you know that this layer will be flattened as part of the process, which is not a big deal because you're keeping that layered Photoshop file around. Okay, so there you have it. PSD is your friend. Okay, let's get real pragmatic. The question I get asked the most is, I don't want to lecture on resolution. Just tell me, do I have enough information to make the print size that I want? And there's an easy way to figure that out without a lot of mumbo jumbo. Go to image size. Okay, image menu, choose image size. And this is the file that you've opened, and you just want to know, do I have enough information to get a decent looking, say, 8x10 print or a 20x30 print on the printer? Here's how you figure it out. First, turn off the resample checkbox. Just make that go away, because whatever you do in this dialog box now is going to be non-destructive. You can change the width, you can change the height. It's not actually going to change the amount of information in the file, so you've protected yourself here. What you're going to do is in the resolution field, you're going to click on the word resolution. That'll highlight that field for you, and just type in the target resolution for the output that you're going to. Okay, I'm trying to make that even simpler. For an inkjet printer, type in 240. You can even go maybe to 300, but 240 is a great number for inkjet printing. All right, so I'm going to type in 240, and look what happened. It made the width and height scale down or change to the largest print you can make without resampling the image, right? Because resample's turned off. Notice that we don't have that turned on right now, so no resampling is going to occur. Type in the target resolution that we've done here, 240, and the result of width and height is now how big a print you can make without actually having Photoshop invent pixels that don't exist. So if you knew you wanted an 8x10, you have enough information. Matter of fact, you can even downsample the file and you're good to go. If you wanted a 20x30, well, you're about half of where you want to be, right? Because if you take a look at the height, that's 14. That's about half of where almost 15. You wanted to be 30. You don't have enough information to do a 20x30. Now, you can make a choice to have a lower resolution 20x30 print. And it's worth trying, right? Go ahead and change it to 20 by 30 and print it out. Your resolution will probably be half of what it is right now. It'll be more like 120 instead of 240. Put it up on a wall, step back 5 or 6 feet, and if it looks good enough, then you have enough resolution. What I'm talking right now, though, is just how big a print can you make with the resolution you currently have present in the file without asking Photoshop to upsample or add pixels to the file in order to accomplish your goal. So if you knew you wanted an 8x10 back as in this example, and you're going to your inkjet printer, you typed in a resolution of 240, you're like, okay, well, that's bigger. The resulting dimensions are bigger than 8x10. How do I resize this back down to an 8x10? Okay, so now you turn on resample and go change the width to 8 if you wanted an 8x10, 8 wide, since it's a vertical image, okay? Note that when resample is now turned on, it doesn't change the resolution that you've already set. It's going to stay at 240. And what part 2 of this exercise has shown you is that this image isn't the same proportion as an 8x10. It's an 8x12 proportion. So I think that would be a 4x3, whereas an 8x10 is a 4x5 proportion. So all this tells you is, oh, okay, I will need to crop this image after I click the OK button. I would need to take off 2 inches, either from the top or the bottom, and create an 8x10 crop before I actually send this to the printer. So there you have it. Easy way to figure out just how big a print can I make. You go to image size, and you turn off resample image first. You type in the resolution you want. Let's say I want a 300 DPI file, okay? The biggest print I can make at that native resolution is 6.4 by 9.6. If I wanted a 5 by 7 in this case, I'm good. If I wanted an 8 by 10, I'm probably close enough. I won't notice any difference in quality there, probably. But if I wanted a 20 by 30 at that resolution, I'm probably not going to get the result I'm looking for. All right, well, now to dial in the dimensions again, turn in resample, turn that on, change the width to what you want it. So in this case, we wanted it to be 5. That gives you a 5 by 7.5 proportion. So in this case, you would just have to crop out 1/2 inch off the height. And there you have it. Hopefully you've now got a really easy way to figure out just how big a print you can make with the file you've got right off your camera. Okay, so you've got an image off your digital camera. You've got a real nice fancy DSLR and shoots 18 megapixels. And you bring it into Photoshop and you're like, I just need to create a 4x6 print of this and put it on an inkjet printer. How do I do that? How do I change the size of my image? Typically what you do is you go to the image size dialog box. It's located under the image menu. So image size. And let's talk about this dialog box because it's potentially confusing for a lot of people actually. Even talking to people who've been using Photoshop for years and they still are kind of confused by what this dialog box is all about. So let's make it simple. I'd break it into 2 parts. There's the upstairs and the downstairs. Upstairs easy, downstairs hard. Now, why is the downstairs harder than upstairs? Because downstairs has one more thing that you have to think about, and that's resolution. We'll talk about that in just a second. The other potentially confusing thing about this dialog box is that it actually has 2 modes. It can be used to resize an image, or it can be used to resample in an image. And there's a difference between resize and resample. The default is to have this turned on to resample. I'm going to turn that off. And note that when I do that, the upstairs becomes unavailable. I can't actually change the number of pixels in the file when resample is turned off, which means all I'm really doing is changing how this image will be printed, what size it will be printed at when you hit the print command. You're not actually changing the amount of information in the file at all, only how it gets output. So I said I wanted a 4x6. So right now the width off the camera, this is a very large dimensionally file. It's 32 roughly inches by 48 inches, but it has a very low resolution. It's 72 pixels per inch here. If I change the width to 4, so 4 inches, because I'm not changing the number of pixels in the file, I'm just changing the dimensions. In this case, I'm making the dimensions go down. Resolution has to go up, right? Because it's the same number of pixels. It's just to fit into a smaller rectangle, the pixels have to get smaller, right? So the smaller the pixel, the higher the resolution. That's kind of how this works. Now, okay, you might understand that. Great. I've turned off resample, which means it's a non-destructive action. I'm not changing the number of pixels in the file. I'm only changing how it's going to print. You click OK, and this is where people sometimes get confused because it didn't appear that anything happened. You know, the file doesn't look different on screen. And that's exactly what's supposed to happen, right? Because you did a resize, not a resample. If I had gone to 100%, let's go ahead and double click on the zoom tool, and I'm viewing the image at 100% view, the actual pixels view. Here you're seeing every single pixel in the image represented by 1 pixel on the screen of the display. You can see there's a lot of pixels here. It's a big file. If I go back to image size, and you can see it's a 4x6 at 584 pixels per inch. Let's take this back to a 20-inch file, so a 20 by 30. The resolution went down in this case because I made the dimensions larger. Again, because resample is turned off, the number of pixels in the file is not changing, so the pixels have to get larger to fill the larger dimensions that we're changing here. I go ahead and click OK, and again, you might be scratching your head going, but nothing happened on screen. So the summary there is when resample is turned off, you're not actually changing anything about the file within Photoshop except how the file will be printed when you use the print command. Let's go back to image size again. And let's take this resolution back to where we started, 72, which forces the dimensions to go up. Let's turn resample on this time. Now when resample's turned on, suddenly the upstairs is available to use again because this is potentially a lossy operation. You're actually going to be changing the number of pixels in the file. You'll either be removing pixels, in which case the geeky term for that is downsampling, or you'll be adding pixels that don't even exist, and that's called upsampling. If I change the width here to 4, the height, retains its proportion by default, so it goes to 6 inches, but note that the resolution did not change anymore because they're not connected anymore when resample's turned on. You can change these independently, whereas when resample was turned off, changing the width or height changed the resolution correspondingly, and vice versa. If I change the resolution, the width and height change. Now, if you take a look at the upstairs, it's actually giving you a clue of what's going on here. The original file was 23 megabytes, but because we made the dimensions smaller and we did not change the resolution, we are throwing away a gigantic amount of those pixels and ending up with a 364K file. And now if I click OK, you're like, oh, something happened. It got smaller on screen. Yes, it got smaller on screen because we actually threw away a large number of pixels. We're still viewing it at the 100% view, and because there's fewer pixels in the file, it takes up less screen real estate to represent the image. Okay, I'm going to undo that. Command-Z, Control-Z on Windows, and go back to image size. Now, when you have resample turned on, which again is the default, you're not just changing how this file will be printed when you hit the print command. You're also changing the physical size of the file, the number of pixels in that document. And like I said, if you change the dimensions smaller and keep the resolution low, you're getting rid of pixels that were present that you don't feel you need anymore. And if you make the dimensions larger or the resolution larger than what you started with, that's called upsampling. You're asking Photoshop to invent pixels that don't exist. So usually a question I get is, okay, I've got this file. It's as big as it can be as it is, but I need to make it a little bit bigger. Maybe I'm starting with an 8x10 image at 300 DPI, and I want to print it as an 11x14, let's say. So how big can you make it in Photoshop? Well, typically what most people say is if you're going up about, say, 25% from your original dimensions, you're probably not going to be able to spot that too badly. You probably get a good enough job there, especially because the larger the print, the farther away you're intended to be from when you're looking at it, right? If you're looking at a billboard, let's say, you're not standing right next to a billboard. You're looking at a billboard from, hundreds of feet away potentially. So you don't need a lot of resolution in that regard because you're going to be looking at it from quite a distance. So anyway, all I'm trying to say is if you're going to upsample an image in Photoshop, going anywhere from 10 to 20% larger than what you're starting with is probably not the end of the world, and you probably won't even notice. If you need to go much larger than that, then there actually are third-party products that do a much better job of upsampling beyond the capabilities of what Photoshop can do on its own. And if that's something you need, I check out one of the products from ON1 Software. It's just on1.com or on1software.com. And they have a product called Genuine Fractals that you can take a look at that does a really good job of upsampling beyond that 20% threshold that I'm recommending you stay within. Last point to make is that if you are resampling an image, whether you're making it have fewer pixels or have more pixels, you actually have a choice of how the resampling gets done. There's another geeky term called an algorithm. What math should Photoshop use to get you the result you're looking for? The default is bicubic, again, another geeky name. And at least now they actually give you a description of what that means. It's best for smooth gradients. There are two other options that you might want to take a look at. One is bicubic smoother. So if you're making that image larger than the number of pixels that you have, you would want to change the algorithm for resampling to bicubic smoother. It's going to give you much better results. Bicubic Sharper is typically what you want to do if you're taking a file smaller, which most of the time, especially with today's digital cameras, you're capturing so many pixels. You typically are downsampling your images, especially if you're posting it to a web page or doing a photo gallery or just showing it up on a mobile device or something. You're certainly not going to send this huge amount of pixels to those particular outputs. So I actually changed my default resampling algorithm to Bicubic Sharper, and I'll show you how to do that in just a moment. But typically, you're going to get a lot better results by choosing Bicubic Sharper. What that does is make the file smaller and does a sharpening pass behind the scenes to retain edge detail. Okay, so if I was doing this as a 4x6 to my inkjet printer, in the previous video, we talked about what type of resolution you need based on output. It turns out that inkjet printing, a good number is somewhere between 240 and 300 dots per inch. We said we wanted this to be a 4x6. And so I'm downsampling this image down to about 4 megabytes. The dimensions are 4x6, the resolution is 240. I've chosen Bicubic Sharper to give me the best results. Go ahead and click OK. And there's my file, and I'm ready to go ahead and print it. If you were following the algorithm discussion there about Bicubic versus Bicubic Smoother and Bicubic Sharper, and you find that most of the time you're going to be starting from a large file and making it smaller, then you'll want to change your preference. Go to Photoshop Preferences on the Mac, and we can just go to General. On PC, we go to the Edit menu, or Command or Control K will just pop open the dialog. And right there in the General category, the image interpolation default, it's right now set to Bicubic. That's the out-of-the-box default. If you're finding you're constantly making your images smaller, then change it to Bicubic Sharper as the default so that the next time you go to image size, that dialog, it will already be set to the interpolation choice that's going to give you the better looking result. Here's a question I get asked actually quite a bit. It's, what resolution do I need my images to be? And to be able to answer that question, you first have to figure out, where are you sending these images? What's your output path for these? Are they going to be printed? If so, are they going to be printed on a printing press, or are they going to be printed to your inkjet printer on your desktop? Or are they going to be displayed on a screen of some sort, whether it be a monitor or a cell phone or tablet device or a netbook or you name it, anything with a digital display? So 3 different categories of output. There's halftone output, there's continuous tone output, and there's display output. Let's talk about each one of those because each one of them has different resolution needs. So let's talk about halftone output first. Halftone output is the word that's used when you are reproducing images on a printing press. There really is no notion of continuous tone on a printing press. You're creating the illusion of continuous tone by using different series of dots of ink on paper. And typically in full color printing, there's CMYK color printing, there's cyan ink, magenta ink, yellow ink, and black ink. And there's 4 different dot patterns, each of a color ink, that when they're all laid and printed on top of each other, make up the illusion of a continuous tone print. A halftone then is a continuous tone image, what used to be a photographic negative or print, that was converted into an image that was made up of dots. So if you take a magnifying glass, or what's called a loupe, to anything printed, like a newspaper or a magazine or whatever, and you actually look at that through the magnifying glass, you will see a distinct dot pattern. That dot pattern is called a halftone. So let's create a new file and just kind of run through some of the things in that new document dialog box that are relevant to this conversation. What resolution do I need for printed output, halftone output? Well, in order to get a continuous tone image converted into a halftone image, it uses something called a line screen. Without getting too technically deep, it's this element that does the conversion from continuous tone to halftone. It generates a dot pattern. The line screen is what is used in that process. And what line screen gets used is dependent on the paper quality and the printing press that you're going to be using for your project. So you may not know what your line screen is. There's actually some standard defaults and industry defaults here. So for instance, if you're going to newsprint, the type of paper that is used for your daily newspaper, typically your line screen is very low. It's 85 lines per inch because the paper quality isn't that great. It's very porous. So when ink hits paper, it typically spreads. The term for that is called dot gain. And so the more porous the paper, the harder it is to hold the shape of a very specific dot. So if you had a very high line screen, higher line screens generate smaller dots. Lower line screens generate larger dots. So if we had a really high line screen and you tried to print that on newsprint, what ends up happening is these very tiny dots just bleed into each other and it becomes one big puddle of ink instead of holding the individual dot shapes. So point being, You may not know what line screen you're supposed to be using, but you kind of might hopefully have an idea of what kind of paper you want. Do you want to use a recycled stock or a matte stock or a smooth stock or a glossy stock of paper? Each paper choice you choose will have a recommended range of line screens for the images that will be printed on them. If you have a good relationship with a printer, they'll be able to tell you what line screen you should be using for the particular paper you've chosen for your project. Once you know what that line screen is, great, you double it, and that's the resolution you need your images to be. So let's say that I'm going to be printing a 7x5 or a 5x7 photograph here. And let's say I started out with a resolution of 600 dpi, or pixels per inch. So I'm going to go ahead and type in 600 in the resolution field here. You can see that's a pretty big file. It's 36 megabytes. Now, if my printer tells me, well, you're using a line screen, or we recommend you using a line screen of 100 lines per inch for this halftone project that you're working on, because you're printing on this particular paper, great. What do you do to that number? You double it. So the resolution I need is actually 200, not 600. So if I change this to 200, look what happens to the file size. What used to be a 36 megabyte file now is only 4 megabytes. So the point being is you may work with really high resolution files during design time in Photoshop, but when you get ready to create the derivative file that you're going to be placing in, say, InDesign or Quark or Illustrator or whatever, you're going to take this file and place it and then print it from, it turns out you don't need to send all that extra information. If all I'm going to do is print a 7x5 at 200, I don't need 600 dots per inch of information. So what it does is it keeps your file size down a lot. It takes up less disk space. It actually prints faster because you're sending a lot less information to the printer. And you just have to let go of this notion that higher resolution means you're always going to get a better looking image. For offset printing, that's actually not true. Sending a 200 dot per inch resolution file versus a 600 dot per inch resolution file for a project that's only going to be using a 100 line per inch screen, the images will look identical when you get them off the printing press if you printed them side by side. There will be no improvement in quality that you'll be able to perceive by sending the higher resolution file. So keep that in mind. Okay, so that second category is continuous tone output. And typically we think of that as inkjet printing, or it used to be an iris printer, and those kind of gone by the wayside these days. But the inkjet is what most people think of as a continuous tone printing device today. You might have a Canon or an HP or whatever. And the target resolution you need for inkjet printing is never really more than 300 dpi. In fact, most inkjet printers assume a default of 240 dpi. So for example, if you're shooting with a Canon digital camera, Canon also sells digital inkjet printers. The default resolution on the camera, when you capture images digitally with your camera, it sets the resolution of those files to 240 dots per inch. So that when you open up in Photoshop, they've already got the target resolution dialed in. So if you were to print that to a Canon printer, it just already is at that resolution. So the reason you don't need to bother about a line screen is that you're not converting your continuous tone image into a series of halftone dots. You are printing it as if you were simulating creating a photographic print in the darkroom. It is the illusion of continuous tone. If you take a magnifying glass to an inkjet print, it will feel more like a photograph than it will something that you printed on a printing press. You won't see a distinct dot pattern. At least if you have a high quality inkjet printer, you shouldn't see a dot pattern. You should just see continuous tone. So again, I never need more than 300 dpi, provided that I'm printing at actual size, right? So if I want this to be a 7x5 photograph, I size it to be those dimensions, I type in the resolution I need it to be, 300, and that's as much information as I need. You can probably get away with much less. That's why the default is typically 240 for some of these inkjet printers. But again, 300 is just a nice, clean, easy number to remember. Okay, so the third category is outputting to a screen of any size, whether it be an iPhone, an iPad, or a BlackBerry, or more of a tablet computer, or a monitor that maybe you're hooking up to a projector. In that scenario, when you're just targeting a device, monitor, a display, you don't actually care about resolution in the typical way we've been talking about it. It doesn't matter what dots per inch the file is set to, the resolution of that file. What matters are the pixel dimensions of the file. And typically you want to target the pixel dimensions of the device or the display that you're going to be representing this image on or displaying this image on. So let's say that I was creating a Keynote or PowerPoint presentation, and I know that I'm targeting my projector, and my projector displays at 1024 by 768 pixels. Great. What you need to do then is change your measurement system in Photoshop, not at inches, but change it to pixels. and then make the width and height of the image the pixel dimensions of the display or the projector that you're going to be hooking it up to. So in this case, I'd make it 1024 for the width, and I'll hit my tab key to jump to the height field and type in 768. Let's say I'm targeting that projector as the image size that I'm going to be displaying here. If it was an iPhone, of course, it would be a much smaller screen size, but you just need to know what the pixel dimensions are of the device that you're targeting. And you can see the file size went down to 2.25 megabytes. Here's what's interesting. Now that your measurement system has been changed to pixels, and I've dialed in some specific pixel dimensions, it doesn't actually matter what number's in the resolution field, because resolution only matters when you print. What dots per inch will the printer use to represent the file when it ends up on paper? If I change this resolution to 1 pixel per inch, I think all of you would agree that that is a low resolution file. The file size did not change. It's still a 2.25 megabyte file, because Photoshop doesn't actually care what the resolution of the file is while you're working on the file in Photoshop. Resolution, again, only matters when you print the file. You're telling the printer what dots per inch to represent the image as it gets printed. So if I change this to 1,000 pixels per inch, again, that you would say that that's a high resolution file, right? But again, the file size did not change. Review halftone output, continuous tone output, or display output. Again, your target resolution if you're creating halftone projects is 2 times the line screen. What determines your line screen? The type of paper you're using and the type of printing press it's being printed on. Who's going to know that information? The printer you're working with. They'll tell you what line screen is recommended. You double that number, and that is your target resolution for your final file size. If you're printing to an inkjet printer, it's continuous tone. Your target resolution is never more than 300. And of course, if you're doing a display graphic, a graphic that's going to be represented on a digital display, resolution's irrelevant. All you care about are pixel dimensions. What are the pixel dimensions of the device that you're going to be presenting this image on? Hopefully that clears up what resolution your images need to be.